Discrete Fourier transform. In this chapter, we'll discuss about computations in DFT.
Discuss with the circular convolution property of DFT. DFT of x of n convolution with h of n equal to x of k into h of k. Convolution in time domain corresponds to multiplication in frequency domain. Here, this convolution is circular convolution because DFT assumes that input signals are periodic. When signals are periodic, that convolution is circular convolution. Circular convolution in time domain corresponds to multiplication in frequency domain. To find circular convolution using DFT, consider two sequences x of n and h of n. Let's say x of n is L point sequence and h of n is M point sequence. L point means L values, M point means M values. To find circular convolution, the first required condition is the length of both the input signal must be same. And that common value of length we will select based on whichever is the maximum length of the input signal. So let's say n equal to max of L comma M. Once this n is selected, both the input signal will have to make it n point sequence by appending signal by zeros. So x of n will append by n minus L zeros, h of n will append by n minus M zeros, and this way the length of both the signal will now become n. After that, we will find circular convolution of x of n and h of n using DFT. To find circular convolution of x of n, h of n, first step, find x of k using DFT. Then find h of k using DFT. Multiply x of k and h of k, we will get y of k. By IDFT of this y of k is y of n. Y of k is x of k into h of k. So by IDFT, y of n equal to x of n, circular convolution with h of n. This way we have to calculate y of n. So we'll take one example. X of n is 1, 2, 3, 4. H of n is 5, 6, 7. Your L is 4. Your M is 3. Select n. N is max of 4, 3, that is 4. We have to do zero padding. That means append a signal to make the length of both the signal equal to 4. X of n is already 4 point sequence. H of n will make it 4 point sequence by appending signal by 0. After that, we'll find x of k. By definition of x of n, multiplied by w n is to k, we will get DFT formula. Matrix substitution, multiplication, will get x of k equal to this. Then we'll find h of k by DFT equation. In terms of matrices, you will get this answer. Next step, find y of k. Y of k is x of k into h of k. This time we have to multiply 1 to 1. 10 into 18, 180. Minus 2 into minus 2j into minus 2 minus 6j, we'll have to multiply this, we'll get this. Minus 2 into 6, minus 12, and so on. IDFT of this y of k is y of n. And this y of n is 50, 44, 34, 52. Algorithm to find linear convolution using DFT. So assume that x of n is L point sequence and h of n is M point sequence. This time we want to calculate linear convolution using DFT. To find linear convolution, the first step is n should be greater than or equal to L plus M minus 1. And then make length of both the signal equal to n by appending signal by appropriate number of zeros. And then find y of n equal to convolution of x of n with h of n. So same algorithm, your output will be linear convolution. X of n is 1, 2, 3, h of n is 5, 6, L is 3 point, M is 2 point. Then select n. N has to be greater than or equal to L plus M minus 1. That is greater than or equal to 3 plus 2, 5. 5 minus 1 is 4. So this has to be greater than or equal to 4. We will take n equal to 4. So we'll make x of n ka length equal to 4 by appending by 0, 5, 6, 0, 0. And now we'll find convolution using DFT formula. First we'll find x of k, then we'll find h of k, then we'll find y of k by multiplying, and by inverse DFT you'll get this answer. This is the linear convolution of two input given signal.
Thank you.